Okay, so if I start with my initial side, I go all the way around, that's 360 degrees, but we're going to be focusing on radians. So 1 revolution all the way around is equivalent to 2 pi radians. Okay, so how much is it if I go halfway around? 180 degrees, right? So half of 360. Also, 180 degrees is equal to just how many radians? 1, so it's only equal to 1 radian. So we would just say 1 pi radian. Good. Okay, and we have our formula, so 1 degree is equal to pi over 180 radians. And that's just solving for degrees or solving for pi using this information here. The other thing is 1 radian is equal to 180 divided by pi degrees. Okay, so our next thing is we're going to use this given information to convert from degrees to radians and then back from radians to degrees. So we're just going to be working some examples next. Okay, so here's about 5 examples where we're going to convert from degrees to radians. Now if we look back on the next page, we can see to go from degrees to radians, we're going to multiply by pi over 180. So I'm just going to multiply this times pi over 180. Okay, now you can cross cancel right there, or you can multiply straight across and just get 30 over 180 and simplify, however you want to do it. But that's going to reduce to what? This goes 1, divide by 30, divide by 30, so then I multiply straight across and we get pi 6 radians. I just cross canceled there. You can do other methods. So our tool for this to go from degrees to radians is to multiply times pi over 180. Okay. So if I divide a 60 is a common factor, so I divide this by 60, I get 2. Divide this by 60, I get 3, and then multiply straight across. 2 times pi is 2 pi. 1 times 3 is just 3 on the bottom, so 2 pi over 3 radians. Okay, so I want you to, after we do this one, we'll work the other two. So just reduce. Don't forget you have a negative sign there. So there's a 60 that can be reduced out of each of these. So using cross canceling, divide by 60, divide by 60, multiply straight across. Don't forget your negative. Negative pi over 3 radians. Okay, I want you to carry out the same process for the next two and then check your answer. Okay, so this one, I simplified and got 3 pi over 2. This one I'm going to need my calculator, so I'm going to say 104 times pi. In your calculator, make sure you use the pi for this symbol. Divide by 180, and it came up to be approximately 1.815 radians. The tool for degrees to radians is going to be to multiply by pi over 180 and simplify. Okay, now we're just going to go from radians to degrees, and I'm going to go back a couple pages and remind you that to go from radian to degrees, we have 180 over pi is going to be our multiplying factor. So that's our tool to get to degrees. So I'll multiply times 180 over pi. Now these pi's cross cancel, so they cancel each other out. And then in the other direction, divide by 3, divide by 3. Or you can simply just do 180 divided by 3 in your calculator to get 60 degrees. Okay, times 180 over pi for our next one. What happens with our pi's? The pi's cancel, and we just put 180 divided by 2, which is 90. And then we remember our negative 90 degrees. Okay, do the same thing for the next two and then check your answer. Okay, here just the pi's canceled and we were simplifying 5 times 30, which would be 150. Over here, we're going to need our calculator because we multiply 5 times 180 and then make sure we divide by pi, and you should get approximately 286.48 degrees. Okay, our next concept we're going to look at is area of a sector, where the last thing we looked at is if I had arc length right here, this was S, we found arc length, but now they want us to find area of a sector, so this is arc length. Area of a sector means they want to know the actual area of this entire piece of a sector. So this is what we're going to focus on next. That's your given formula, and I'll write the first example down. Okay, so our first example is find the area of a sector of a circle of radius 5 formed by an angle of 60 degrees and round your answer to 2 decimal places. Now, our formula is equal to 1/2 radius squared theta. But remember, when we're working with the arc length and area of a sector, we have to have our angle in radians. So what did they give us our angle in? Degrees. So before we can actually plug this into our formula, we have to convert 60 degrees to radians, which means we multiply times pi over 180. So what we just did a minute ago. Reduce that, 60 over 180, simplifies to just 1/3 or pi thirds. So this is going to be my angle. Area is equal to 1/2. My radius is 5. It's given right here. Squared. And angle theta in radians is pi over 3. Now we can simplify this and we would have 1/2. 5 squared is 25 times pi over 3. Plug all that in and simplify. That's going to be equal to 25 pi 6, or approximately, when we put it in the calculator, 13.09 feet square. So this would be an exact answer, and this is your approximate answer. Find area. They give us radius and angle theta. Remember, angle theta needs to be in radians, so we want to convert 45 degrees to radians. Reduce that and simplifies to pi fourths. And plug it into our formula. Area is equal to 1/2 radius squared theta. Radius is 4, so 4 squared, and theta ends up being pi fourths. So 1/2 times 16 times pi fourths would just give us 16 pi over 8. So that's just going to end up being 2 pi, which is approximately, 2 pi is approximately 6.28. And since its area, we'll say meters squared. Okay, we're going to change it up a little bit for this next one. I'm going to give you theta, and I also gave it to you in radians already, so no conversion step. Give you the area, and you find radius this time. So plug it into this formula and solve for r. So write my formula down, plug in 2 for a, right there, 1/2 r squared, and plug in 1/3 for radians. I'm going to simplify. So it's just going to give me 2 is equal to, right here, I'm going to say 1 times r squared is just going to be r squared over 2 times 3 is 6, or I can say 1/6 r squared. If I'm solving for r, I can multiply by the reciprocal, which is 6. Whatever you do to one side, do to the other, so multiply times 6. And that would leave me with 12 is equal to r squared because this 6 cancels with that 6. Now, how do you get r by itself? Good, take the square root. Whatever you do to one side, do to the other. So square root of 12 is equal to r. But we want to go off to the side and break that down like we did before. Let's see if that radical simplifies. So let's divide a 2 out of it. Divide a 2 out of it, and we can stop. Now remember, because our index is a known 2, we're going to do pairs of 2. So that means a 2 gets to come out front. This 3 does not group up with anything else, so it's stuck under the radical. So basically, that's 2 square root of 3 is equal to the radius. That's the exact answer, or if we put that in the calculator, we would get approximately 3.46 feet, something like that. So this is the exact answer, and this is the approximate answer.